Hi and welcome to the Saber Card Mini-Kit assembly video. So we're going to be assembling this mini-kit today. It's all surface mount components, so we are definitely going to need a very fine tipped soldering iron, and we're going to start with the LEDs. So the LEDs have a faint green mark on one side of the top. That indicates the negative side, and that should be aligned with the minus sign on each of the footprints. Be careful not to ping these across the room because they are very difficult to find, especially if you've got carpet. We've given you 4 extra, so use them sparingly. When soldering these surface mount components, what we want is a very shiny tinned soldering iron tip, so the solder goes where you want it to go. And what we want to do is solder one of the pads for each of the components. If you're right-handed, solder the right pad as you're looking at it. If you're left-handed, solder the left pad. You'll be holding the tweezers and the component in your non-dominant hand. So you're going to pick up the LED in the tweezers and make sure it's the right orientation. So you see the minus sign on the left hand pad there, that green mark on the LED will line up with that. We're going to heat the solder and push the LED into the molten solder, lift away the soldering iron so the solder then solidifies, holding the LED in place. We're going to do that for all the LEDs, noting the polarity for each LED. We can now do the same thing for the clock indicator LED at the bottom of the board. And then solder the other pads. If the solder isn't behaving as you think it should, then you probably need to re-tin your iron. I definitely need to do that here, but I'll solder on. Now we can move on to the 2K resistors, which are the current limiting resistors for the LEDs. You can find them in a strip of 4 resistors with the number 202 on them. Just like the LEDs, we're going to solder the one pad and then offer it up, stick it in place, and then solder the other pad. Remember to tin your soldering iron often. It's much harder with a dull tip, I promise you. So now we're going to solder R1 and R2. I've selected the 10K resistor for both of these. Changing R1, R2 or C2 will change the speed of the frequency of the clock pulse, which will change the speed of the animation, as it were. Lowering these values will increase the frequency, so will increase the speed of the animation. Increasing the value will lower the speed. You can check out the calculators on the Saber Card information page on the website, link in the description. Now we're going to move on to the capacitors. The first capacitor, C1, is the 100 nanofarad capacitor. The same method as always. The value of C2 is up to you. You can experiment and try different values here to speed up or slow down the clock pulse. I'm going for a 4.7 microfarad. So moving on to the chips, these are definitely the most difficult part. The orientation, if you see the circle on the chip top right as you see it on the screen here, corresponds to the circle next to the pad on the circuit board. So if you line these up, what we're going to do is solder one pad, just like the LEDs and the resistors and capacitors, and then we're going to move the chip in place and solder that one pad. We can then flip the board and solder the opposite diagonal pad and to keep everything in place, and then go ahead and solder each pad individually. Again, a thin soldering iron tip here is absolutely crucial, and also thin solder. So this is 0.4mm solder, I believe. Thick solder, you're just going to get solder everywhere, and it's going to bridge the pins. If your solder isn't going where you want it to go, again, tin the iron and make sure it's nice and shiny. We're heating the pad and the pin together, so the solder wicks onto both of them. We can do the same with the 4017, the bigger chip. So there's more pins, but it's exactly the same. This doesn't have a little circle on it, so as you can see, there is a line. You can line that up just like the other one. So we're soldering the one pin and then soldering the diagonally opposite pin. So I'm not happy with the positioning here, so I'm going to reflow the one single pin that I've soldered already. If we had multiple pins here, that would be very difficult to do. That's why we solder one at the beginning. And when I'm happy with the position, then I can solder the diagonally opposite pin. Now it's a good time to re-tin my iron. Then we can go ahead and solder the rest of the pins. Once all the soldering's done, we can add a bit of flux to everything, just to reflow all the solder so that it's nice and shiny and everything's all connected properly. Just tidies everything up a bit. So we're adding a load of flux here, and then we're just going to touch the iron to each of the solder joints to reflow them a little bit and neaten everything up. What you can get is little spiky bits if there's not a lot of flux in your solder, and this will sort those out. Now to get rid of all that flux, we're going to need to use some isopropanol and scrub that clean. Might take a couple of tries to get all of it off. Use a bit of tissue to wipe it off, and then try again until it's nice and clean. And there we have our soldered Saber card. So now we can test for continuity. You can do a visual check, especially if you've got a microscope or a magnifying glass, and that should be fine. But just to make sure, we can use our multimeter in continuity mode and touch the two probes to each consecutive pad on the chips, just to make sure there's no continuity between pads that are next to each other. So what happens if you do have a solder bridge? Well, what you do is add some flux. Make sure your soldering iron is nice and tinned again. Add some solder, wipe it off. And then we're going to drag that solder tip through the middle of those two pins, which should wick away some of that solder and remove the bridge. You can wipe off any excess solder if it's taking a while, and then come back at it and make sure that there's no solder left between those pads. Now we can come in and clean with isopropanol again and dab it with a tissue and do all that good stuff, and we can then test it again with our multimeter. And that's it, we have a soldered Saber card. So we can then power test our board with anything from 4.5 to 16 volts. And if you're not happy with the speed of the animation, you can experiment with different values for C2, R1 and R2. Now we're going to demonstrate removing a capacitor and replacing it with a different one. So we're going to make sure our iron's nice and tinned, nice and shiny. So add some solder, wipe it off, and then we're going to apply some heat to one of the pads of the capacitor. Now capacitors are great because they conduct heat pretty well, so the heat will conduct through the capacitor to the other pad and melt that solder, so you can just remove it. Resistors and LEDs don't conduct heat so well, so I would add a lot of solder to your soldering iron and try and heat both pads at the same time. So once that's removed, you can add the replacement. So what I'm doing is heating the pads one after the other and pushing down a bit on the capacitor until it's nicely seated. Right, thank you very much.